Right. Everything you just did the long way, right? You just plugged in the numbers. So I'm going to give you an example here. This one's actually with that shortcut rule there. The sum of I equals n times n plus 1 over 2. So if we were to do this the long way, then we start at 1, we go to 9, so we have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. Alright, pretty simple one to do the long way. And so you'd add those together, and when you add those together, you'll get 45. Alright, so that's the long way to do that problem. It's really not that bad to just do that the long way. So if you have something like this, you could do it the long way. But if you have, like, let's say we had 100 and we didn't have a calculator, that's going to take a really long time. So the shortcut that you can use is if you have a sum from 1 to n of I, you can do n times n plus 1 divided by 2. So here we could also do 9 times 9 plus 1 divided by 2. Which is going to give us 9 times 10 divided by 2. So 90 divided by 2, which is 45 also. So you can see when you have really large numbers, that's a lot quicker to do. When you have small numbers like we've got here, the difference really doesn't matter all that much. So let's go on to some more complicated examples. The shortcuts for I squared and I to the third are here. So we are going to keep those in mind, although we don't need them for example 8. But they are different than if we have just I, or they are different than having just I. So like on example 8, the first thing that we need to remember is an n is a constant number. Like for this one, I know n is 10. So that n squared, I can pull out front, right? It's a constant. Or I can think of this as I equals 1 to 10 of I plus 1 over 10 squared. And so that is just a constant. Constants, just like with integrals or with derivatives, constants can be pulled out front so that you don't have to mess with them. So we can do this 1 over 100 equals the sum of I, from I to 10, of I plus 1. Oh, I'm sorry, that shouldn't have an equal sign, that should be multiplication there. And then we can take the sum of I and 1 separately. So we can make this 1 over 100 times, I'm going to write this out separately, the sum of I plus the sum from 1 to 10 of 1. And then, or I could just go ahead and do this the long way. I could just plug in 1s, 2, 3, 4, 5, 6, 7, 8, 9, 10 to this. So I could do this the long way. But let's try to use those shortcut rules because on Monday we're going to have to use those shortcut rules to, as we've been talking about, we need our number of rectangles to approach infinity, which means we need really big numbers, so we got to use those rules. So, so we've got 1 over 100 times, the shortcut rule for I is our n times n plus 1 over 2. So we're going to do 10 times 10 plus 1 over 2. And then what's the shortcut rule when we just have a constant? The c times the n, so 1 times 10 in this case. Okay, so here we're going to have 110, let's see, yeah, 110 divided by 2, 55, right? So we get, oh, you're adding another 10. Okay, yes. So we get 100, and then we've got, this is 110 divided by 2 is 55, plus 10, we get 65. So that gives us 65 over 100, which I am just going to make into 0.65. So rather than starting at 1 and going to 10, I can do this. I'm not sure how much quicker it is. Certainly if you got really big numbers, it becomes a lot quicker than just trying to plug in those numbers over and over again. Okay, here's our next one. Now this one we've got to go from 1 to 15. So that is a lot larger number that we would probably rather not have to do. We would have to do 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared all the way up to 15. If you don't have a calculator, that's really going to get into some large numbers that you don't want to have to try to add all together. So we're going to use our shortcut rules on this as well. So if I sort of break this up, that n I can take on the outside, right? And what is my n for this one? 15. So I'll have 15, and then I will have the sum from 1 to 15 of I squared minus the sum from 1 to 15 of 1. And so when you have this, 15 will stay out front. The shortcut rule for I squared is n times n plus 1 times 2n plus 1 all over 6. So that n is 15, so we've got 15 times 15 plus 1 times 2 times 15 plus 1 all over 6. And then what will we have for the 1 times 15? So we got 15 times 16 times 31. I'm going to go ahead and cheat and use the calculator on that just because I don't need to know how good your longhand multiplication is. I think on the actual, I don't think you're going to see this on the actual exam, really, but you never know. But usually they give you nicer numbers. So if I do 15 times 16 times 31, I'm going to get 7,440 over 6 minus 15. And so if I divide that by 6, I get 15 times 1240 minus 15. So we got 15 times 12, 25. Here's in the way. And that's going to give us 18,600. Hold on. I did that wrong. I did 1240. 1225 times 15. It's going to give us, there we go, 18,375. That's better. Okay. Questions? Whenever we do these for homework, it is perfectly fine with me. Try to do small numbers in your head, like we were doing those first ones, just because that's good mental math practice, and you'll probably see stuff like that you've got to do on the exam without a calculator. When you get into stuff like this, just go ahead and use the calculator so that you're not spending 5 minutes on a problem that you could have done in 30 seconds with the calculator. So, questions? All right. The next thing I want us to look at is we need to be able to take a series and write it with sigma notation. So we need to be able to take what we've got here and go to something that's written with sigma notation. So if I look at A, I'm going from 1 to 7. It just looks like I'm counting, right? So I would have the sum, and I would start at 1, and I would go to 7, and it would be of what would be my expression? Just I, or whatever letter you want to use, but I use the I there. All right, and this would just count 1, 2, 3, 4, 5, 6, 7. Okay. Questions on A? All right, for B, what number do you see that is changing each time? There. The number that's squared, right? We've got 4, 5, all the way up to 9. So that's your variable. So let's use a different letter just because we can. Let's say we use a K. We've got K squared plus 1. And so you're doing the sum of K squared plus 1 from K equals, where do we start for this one? 4. And where do we end? 9. Okay. If we look at C, what do you guys see changing? Whatever's over N, 1, 2, to N, right? So basically you're going to take what you've got, 1 over N times 6 plus whatever letter you want to use here. Let's use a I again. Don't use a N. That's the only letter that you cannot use. I over N. Basically, you just take whatever that is that's changing and turn it into your variable. And then we would be doing a sum from, where do we start? 1. Where do we end? N. Okay. What about for D? What do we see changing? The 1 over N squared, so this 1 to N right here changes. So basically we're just going to take N square root of 1 plus, let's call it a J this time just because we can, J over N squared. So this would be the sum. Where do we start? Where do we end? N. Okay, questions? Alright, so what you guys are going to do now is go to page 299, and we are going to do 13 through 20. There. Try to do them without your calculator. This time I want you to try to use shortcut rules on ones where it makes sense to use shortcut rules. You can use that note card to help you